All right, and then another piece of weather is what is called inversions. And inversions are when the normal weather patterns of warm air or of air being heated up at the surface and rising is not allowed to happen because of something that blocks it. So the air generally becomes cooler as altitude rises, and since warm air rises, we get vertical mixing, which is where we have air rising and eventually coming down. And because of that, air pollution gets to be carried away from its source as the warm air rises with altitude. Okay. However, during a temperature inversion, what happens is a layer of cool air becomes trapped beneath a layer of warm air. I have another picture here because I feel like this one is better. So this is normal, warm air, colder air, it cools as it rises. Here we could get what's called an inversion layer, where warmer air traps the cooler air below it. And what happens with that is now the pollution gets trapped below it because we don't have the vertical mixing anymore. It is stuck right there. And so this is called the inversion layer. And it's since the relationship is opposite of normal, and these often can occur. There's many different kinds of temperature inversions. This one would happen because it's trapped between two mountains, so this can occur in a valley like this. So nearby mountains block morning sunlight, creating cooler air in their shadow, and it traps the pollution near the ground. Sometimes the temperature inversion can happen lower in the atmosphere, sometimes higher. But what happens is it can trap the pollutions from leaving and create bad air quality in a given area. In 1996, there was a temperature inversion in Mexico City, which was a 5-day crisis where at least 300 people died and 400,000 people went to the hospital because of the terrible air quality that happened. And so large-scale circulation systems create or produce global climate patterns. So we have a lot of global climate patterns. And that's because of the convective air currents. Hot air rises, becomes cold air, falls, comes back down, etc., etc. We have these things called Hadley cells, and they are convective cells called Hadley cells, and it's rapid rising and expansion of air due to intense sunlight, and that's what gives us the tropical rainforests. We are not going to spend a lot of time on the Hadley cells, but basically what happens is they are these small currents where the air will rise, cool, and then fall, and they always tend to happen in about 30-degree latitude patterns. The way that the air will rise, cool, and fall tends to happen at about in the same distance, and so it creates weather patterns. So we have hot air leaving at the equator, and then what happens is we have dry regions where the air falls and cools because there hasn't been, that lost all its moisture up here. And just the important thing to know here is that the reason for this, so the Hadley cells begin at the equator and move outward, and it creates dry regions that are 30 degrees south and 30 degrees north because the cool dry air is falling there. This also can explain why we have certain biome patterns, and they tend to be latitudinally placed. So around the equators where the tropical rainforests are, and we'll see deserts at around the 30-degree mark. So these Hadley cells, because they're happening in the same pattern, are creating these climate patterns. You don't have to worry about all this other stuff, but this is a Hadley cell. Warm air rises, we have the precipitation, so dry air falls and creates a dry region at 30 degrees north and 30 degrees south of the equator. All right, then we have two big kinds of storms we're going to talk about. The first one is hurricanes. And so hurricanes form when winds rush into low pressure systems containing warm, moist air from tropical oceans. So remember that anything, not just air, but also water and anything else.
Ariana Drake to the office, Ariana Drake to the office, Ariana Drake to the office now.
That's going to happen. Things will always move from high pressure to low pressure. So winds are going to rush into low pressure systems that have warm, moist air from tropical oceans. These winds rush in and they start to move counterclockwise in the northern hemisphere due to what's called the Coriolis effect. And so it creates these big weather patterns where now there's this rapid intake of warm, moist air, and it leads to very heavy amounts of precipitation. So these tend to happen most commonly on the Gulf Coast, on the Atlantic coast. We don't really get hurricanes over here on the Pacific side of the country. They can sometimes be called typhoons or cyclones, and basically there's just really powerful convective air currents that draw up tons of water vapor, so then it comes back down as lots and lots and lots of rain as the air cools, rises and cools. Then we also have tornadoes, and tornadoes form when a mass of warm air meets a mass of cold air, and then the warm air rises rapidly, setting a powerful convective current in motion. So it's basically they meet each other, and the warm air rises so fast that it starts to spin sometimes. And if low and high altitude winds are blowing in different directions, that is what will cause it to spin, forming a tornado. So these may lift up soil and objects in its path with winds up to 500 kilometers per hour. And in North America, these are most common in the Great Plains and the southeast part of the country. We don't really get tornadoes here either.